Water is essential for life, and organisms could not live without it. So, for example, in us, about 55 to 60% of our body weight is actually made of water. So for women, it's 55%, and for men, it's 60%. And the reason there's a difference is because, unfortunately, in women, we have more body fat than men do, which kind of stinks, but that's just the way it is. Okay, so what makes water so special is it is a polar molecule. So remember that there are polar covalent bonds between the hydrogens and the oxygen atoms. And that's because oxygen is an electron hog, and it likes to pull on the electrons more than the hydrogen atoms do because they're pretty wimpy. And so the electrons spend more time around the oxygen atoms, around the oxygen atom than the hydrogen atoms, and so you're going to end up with a partial negative charge on the oxygen atom and then partial positive charges on the hydrogen atoms. So these straight lines here, those are representing the polar covalent bonds. And then water molecules will also form hydrogen bonds. And remember, hydrogen bonds are going to form between the partial negative charge and the partial positive charge of two polar molecules. So here we've got the partial negative charge on the oxygen of one water molecule, and then the partial positive charge on the hydrogen atom of another water molecule. And so that's a hydrogen bond right there, and we represent that with that dotted line there because it's a pretty weak bond. So water exists in three states. So the solid state is ice, and because of the cold temperatures, the water molecules are not moving very fast at all, and so hydrogen bonds will form between all of these water molecules. And with all of those hydrogen bonds, that will spread the water molecules out, and that will allow the ice to form. And the ice is actually going to be less dense than the liquid water is, and so the ice actually will float. And so that's why the ice cubes will float in your glass of water. And then at a warmer temperature, the ice will melt, and we have liquid water. And so at a warmer temperature, the water molecules are moving faster, and so they will form hydrogen bonds with other water molecules, but then they break as they move on. And so the water molecules are actually going to be closer together as they form and break their hydrogen bonds. And then at an even warmer temperature, we've got the gas phase, the steam, and the water molecules are moving really quickly, and they're going to be spread pretty far apart, and there will be very few hydrogen bonds forming here. Okay, there's actually 4 properties of water that make it so that life is possible on Earth, and these properties of water are due to water's polar covalent bonds and its ability to form hydrogen bonds. So the first property we're going to be talking about is cohesion. And then we'll talk about the ability of water to moderate temperatures because of its high specific heat and high heat of vaporization. And then ice being able to float because it's less dense than liquid water. And then water also makes an excellent solvent, so it's really good at dissolving things. So we'll look at cohesion first. So the term cohesion just says that water molecules will stick to other water molecules by hydrogen bonds. And a good example of cohesion is the surface tension of water. And surface tension is just a measure of how hard it is to break the surface of a liquid. And then adhesion is just water molecules sticking to other polar molecules by hydrogen bonds. So we'll take a look at both of these things. So here's cohesion. We've got water molecules sticking to each other by hydrogen bonds and creating this surface tension. And because these water striders are light enough, they don't break through the surface tension and they're able to sit on top of the water. So that's an example of cohesion with that surface tension of the water. And then we can also have cohesion and adhesion occurring together, and that's what happens to draw the water up the roots and up through the tree here and up into the leaves. So we've got cohesion. If we look at this close-up view here, we've got water molecules sticking to each other. That would be cohesion by hydrogen bonds. But then what keeps the water from just falling back down by gravity, back down to the roots, would be adhesion, where the water molecules are going to stick to the inside of these water conducting tubes inside the tree here called xylem. And so they're going to stick to other polar molecules here in the wood. So that would be adhesion. Okay, and then we can also take a look at capillary action. So like when you put your straw into your drink, you probably have noticed that the water will rise up the straw a ways. And that's an example of adhesion and cohesion as well. So you've got the water sticking to each other, so that would be cohesion. And then we've also got the water molecules sticking to polar molecules on the inside of the straw surface, and that keeps the water column from falling back down by gravity.